Hello, welcome back to SP Classroom YouTube channel, the place for creators of creativity. This is the session for one of the powerful tool in electronics projects or electronic circuits called Arduino. A small circuit but very powerful. We can create wonders through this device. Before getting started to the tutorial of the Arduino, let me explain why microcontroller. Because the one who is very new to electronics projects will not get idea about microcontroller without knowing why it is. This video may be a little bit lengthier because I need to cover the topics of why microcontroller, what is Arduino, hardware parts of Arduino board, download and installing of Arduino software, and let's upload a simple program to our Arduino board. I am sure by the end of this video you can upload a program to your Arduino board, and by the end of next video you can write your own program to do some projects. Please stay tuned in this channel. Make sure you have subscribed and press the bell icon. Then only you can get the instant notification when I upload new videos. Let's begin. In any electronics projects mainly consist of three units. Sensors, which senses the physical environment, processing or controlling unit, which takes all the decisions in the system or which controls all the functions in the system. And another one is a transducer or actuators, which gives the physical output. The physical output is nothing but we human can understand in the form of light, sound, heat, in any manner. The duty of sensors and transducers is to just convert the signals, because we know that the electronic circuits or electronics devices can only understand electrical signal, and we human cannot understand the electrical signal. Then how we can interact with these electronics devices? Because in our day-to-day life we are using a lot of electronics devices like our phone, computer, TV, everywhere we are using. So we must to interact with these devices, right? Just take an example of an amplifier that we are using. We can't speak loudly, but that amplifier can do that for us. But how? Will you think our voice or sound wave, audio signal is directly going through that wire and amplify that amplifier, and again it's going to that speaker so we can hear our voice loudly? No. There is a sensor called mic or microphone which will convert our voice or audio signal to the electrical signal. That electrical signal is amplified at amplifier. That amplified signal is converted back to original voice or audio signal by a transducer called speaker. Look at the flow. The physical signal is converted to electrical and processed, and that processed electrical signal is converted back to physical form. By relating these inputs and that output through a processing unit, we can do anything in electronic circuits or electronics projects. But the sensors and actuators having its own dedicated functions. We can't change or we can't do anything in that. But the processing unit is not like that. We can change or do anything in that based on our requirement. Take the previous example. In that amplifier, the mic, it will just convert our voice or audio signal to the electrical signal. We can't do anything more than that. But in amplifier or that processing unit, we can increase or decrease the gain of that volume, or even I can change it from male voice to female or female voice to male voice or any robotic voice. Anything I can do there. But this speaker will just convert that processed signal, electrical signal, to the actual voice or audio signal. So the processing unit or microcontroller is the heart of any system, which will take the decision based on our requirement. It's like we are appointing a person to do particular work. For example, I have an office and I appointed a watchman in that, and I am giving instruction that if any person without my company ID, don't allow them to come inside. So that watchman is taking the decision to allow or not to allow any person to come inside based on my instruction. Same way the microcontroller or processing unit will take the decision based on our requirement or our instruction. I can change my instruction at any time. Like now I am telling that watchman to allow the person who have any ID card to come inside, and the person who don't have any ID card, just note down their information and allow them to come inside. So the watchman is now taking the decision based on my new instruction. Same way the processing unit or microcontroller will take the decision based on our latest instruction. I can change my instruction over and over. How I gave instruction to that watchman in his language. Same way the processing unit have its own language called programming language that we can learn later. Let's explore the Arduino board. Even in Arduino, there are many versions are available like Arduino Uno, Arduino Mega, Arduino Nano, Lilypad, etc. But one of the popular board is Arduino Uno. You can buy it online if you really want to learn it, because we can remember 5% of what we hear, 10% of what we write, and 95% of what we personally did. So buy an Arduino and start to play with it. The link is given in the description below. But I recommend you to buy an Arduino starter kit because it's coming with all necessary devices like many sensors, LEDs, resistors, breadboards, which are all required for doing basic projects in Arduino boards. The link for starter kit also given in the description. Otherwise, you need to buy it separately for each experiments. I hope you get an idea about why microcontroller and what's Arduino and why it is using. Let's move to the Arduino hardware parts. You can see a small circuit board which consists of many tiny components. I'm not going to explain all because it's not needed for doing projects and also it may be boring to you. It's called Atmega 328P microcontroller. Now you know why they provided microcontroller. The program what we are writing to the Arduino board is stored in this chip. It having 2K RAM and 32K flash memory. It's more than enough to store our program and also having features like timer, UART, serial port, I2C and SPI protocol. You may come to know that what is the use of these features in upcoming videos. The remaining all components are to support this microcontroller, like USB port to connect our computer to this microcontroller. Through this port, we are going to load or store our program from computer to the Arduino board. It needs a to B USB cable. The power port to provide power supply to the board. If you are connected this board to our computer through the USB port, additional power supply is not required. The USB cable is capable of supplying power too. But in real applications, we cannot connect our computer to the board every time. So in that situation, an external power supply is required. We can connect AC to DC adapter or battery up to 20 volt. But remember, the Arduino is working at 5 volt only. For that purpose, a voltage regulator is provided in the board. Through this power port, you can supply a 9 to 20 volt. The voltage regulator will regulate it to exact 5 volt, so the board is safe. The I/O pins for interact external devices with the microcontroller. These pins named from 0 to 13 called digital I/O pins. We can use this pin as either input pin or output pin. When used as input pin, they can read the signal from input devices. When it is used as output pin, they can actuate the output devices. It can supply 40 milliamps of current at 5 volt. Some of the pins are labeled with a wave symbol. You can see here pin number 3, 5, 6, 9, 10, 11. These pins act as normal digital pin but can also be used for pulse width modulation, which is similar to analog output. These are analog pins. It can read the analog values from any sensors. Now you may get confused. What is analog and digital? There are terms like analog pin, digital pin, analog output, digital output and all. Digital means there is only two states, either on or off. In electronics term, we can say it as high or low, or 1 or 0. All are same. On means 1 or high, off means low or 0. I told that Arduino working at 5 volt. So the digital output means it can give either 0 volt or 5 volt. Take an LED connected to the digital pin. Then I can only turn on that LED or turn off that LED. But the analog pin is having the value between 0 and 5 volt. Any value from 0 to 5 volt it can supply. Take that previous LED. I connected that LED to analog output pin. Now I can change the brightness of that LED by supplying exact voltage, because we know that brightness of LED is based on the input voltage. Same way the digital input and analog input. The digital input can read only two states, either 1 or 0. But the analog input can read the value from 0 to 5 volt. Between 0 to 5 volt it can read any value like 2.5, 2.8, 3, 4.5, any value from 0 to 5 volt. There are some sensors giving analog value, some giving digital value, that I will explain later videos. There are some power pins. We can take the power from board to our sensors or any other devices. The 5 volt pin can supply 5 volt and 3.3 volt pin can supply 3.3 volt, and these are the ground pin to ground our circuits. The V-in pin same as power port. We can give the power through this pin also. AREF stands for analog reference. Most of the times we are not using this pin. It is sometimes used to set an external reference voltage. For example, I am using an accelerometer sensor which is working on 3.3 volt and giving analog value from 0 to 3.3 volt. That time I can make the reference voltage of 3.3 to measure from 0 to 3.3 volt. There are some LEDs on the board. Power LED for power indication. When the board is connected to the power supply, this LED must light up. If does not turn on,
on, there is something wrong in the board or power supply. The TX and RX LED is for serial communication indicator. Whenever the board is transmitting or receiving the data, this LED will blink. The debug LED marked as L is built-in LED on pin number 13. We can use it for testing our program without connecting an external LED. If I want to reset the board, that is I want to run the program which uploaded to the board from beginning, then I just need to press this reset button. It's same as unplugging the board and plugging it again.
Now we understood what is microcontroller and learned different parts of the Arduino board. Now we have to communicate with this Arduino board. For that we need a software called Arduino IDE or Arduino Integrated Development Environment. It's freely available from their official website. The programming language for Arduino is very easy. I will give you a basic tutorial of the Arduino program in next videos. Let's go to downloading and installing part of the Arduino software. The Arduino IDE software is free to download. We can download it from their official website. The link is given in the description below. The installing is very easy. Just follow these steps.
Click the link in the description. It will redirect you to download page. Or open your browser and visit the web page. There are versions for Windows, Mac and Linux operating systems are available. Select your operating system. I am using Windows PC, so I am selecting Windows operating system. Click on the Windows installer option for the easiest installation. And click the download. The file size is about 110 MB. It will take a while to download. It starts downloading and save the .txt file to your hard drive. When the download is finished, open that .exe file. Grant administrator permission. Click the button to agree the licensing agreement. Decide which components to install, then click next. Accept the default installation folder or pick another one. I am selecting the default folder. Then click install. Install USB driver. Then click close. Now find the Arduino shortcut on your desktop and click on it. The IDE will open up and you will see the code editor. This is the first look of Arduino IDE. The main white area of the IDE is the area where we write our code. The code you write for your Arduino is known as sketches, so this is called sketch file tab. This area is called status bar. It will indicate status of your sketch. Program notification area. Here all the details of your program will be displayed. At the top left of the IDE, you will find 5 buttons. He is called quick action tab. The first one, which looks like a check sign, is the compile button. When you press this button, the IDE will try to compile the code in your sketch. You will find the upload button. Once this button is pressed, it does the same thing as the compile button. And if your sketch is free from error, it will send the code from your computer to the board. The next 3 buttons are quick buttons for opening a new sketch, opening an old sketch, or saving your sketch. At the far right of the IDE, you will find a button that looks like a magnifying glass. This button will open a new window that lets you see a communication window to send and receive the data from the computer to the board. Okay, now let me show you the demonstration of how it's verifying the code and showing the details of that code in notification area. It's done compiling and showing the details of that code. Now I am trying to make a mistake in that code. To monitor the error in that code or sketch, it will show the error in status bar.
Okay, now you understood what is Arduino and the hardware parts of the Arduino board, and the Arduino software is installed in our PC or computer. Let's do a simple experiment in it by uploading a simple sketch or a simple program. Before jumping to that part, make sure you have all these right equipments. One Arduino Uno board, A to B cable, and a computer with Arduino software installed in it. Okay, well, what we did now, just uploaded a example program to blink the inbuilt LED of the Arduino. The Arduino IDE is preloaded with many examples. You can go through that. Okay, now I want to change the blinking speed of that LED. So I have to modify that program to my requirement. As I told, we can change or modify our program or our instruction number of times. So let's do a simple modification in our program to change the blinking speed of that LED. Okay, well, we did it in our inbuilt LED. Now I want to connect an external LED to blink. You can take any pin from these digital I/O pins. I am taking pin number 8 to blink this LED. Now we can see the difference between digital and analog values, but I can't do it for pin number 8 because it having only digital output or digital input property, but the pin number 9 having the property of both digital and analog output. Okay, now I am changing that wiring to pin number 9, and I need to do a modification in our instruction or our code. I hope now you are ready to play with Arduino. If you have any doubt or you want more clarity, let me know in the comment section. Because my purpose is to be helpful for you from this video. In next session, we will learn Arduino programming to write our own program, and let's do simple experiments. Hit like button, share with your friends, and make sure you have subscribed this channel. Thank you for watching, and we'll see you in next video.